Here we're posed with a problem with having this bracket which is fixed to stationary surface there at A. We have two ideal pulleys there at B and C. Cable which is wrapped around these pulleys. The left-hand side of the cable there at D is fixed to ground, and then there's someone pulling on the right-hand side with a load there at P. What we want to know as a result of this are what are the reactions acting on the bracket there at end A. So to get to that point, what we need to do is draw a free body diagram. I'm going to choose to draw a free body diagram of the bracket, the pulley there at B, the pulley that was at C, the pulley there at B, and then including in this part of the cable which goes like this. So basically making a cut here and making a cut there. The reactions that we have are going to be the ones we're trying to find, which is AX and AY. Since it's built in, we're trying to find the couple there at A. Since the cables or the pulleys are ideal, the tension is unchanged all the way through. So if the tension on the right hand side is the load P, it's also the same tension there on the left hand side. So that is our free body diagram. I'm going to make X positive to the right, Y up, summing forces in X. I've got the reaction force AX plus P minus P, and therefore we see the interesting result here is that there's no reaction there, X direction, at the support point A. I sum forces in Y. I get AY, and since that's the only force which is acting in Y, it says that that reaction force component is a 0. Then I'm going to do a moment about A. Moment about A, I pick up the couple due to the wall, which is what we're trying to find. As I find the moment arm for this load there, P, that's going to be P with a moment arm of 5 times R. There is 4 here. I think this should be a 4. 4 plus 1, that's a 5. That is going to be in the minus direction. The moment arm about point A due to that force P, that is going to be hit force P. It's going to be a moment arm there of 3R, and it too is going to be a minus. Do I have that right? I don't. I got the moment arm right, but I see here with P acting to the right, we're looking for a moment about A. The right-hand rule would make that a plus. And so from this equation then we get that the couple at the wall is nothing other than 2PR. So it's interesting that there's no reaction force at the wall, the connection point there of A, but there is a couple. And we can reason this out because if we just look at the effect of this right here, let me just sketch this out what I'm focusing in on. Look at this, this, and this. We see that the loads there, P, they form a couple. What I mean by that is 0 net force. That's why there was no reaction force there at the wall, and the moment due to those is equal to the load P times the distance between their two lines of action, so that's 2 times R. So it all makes sense when you look at it from that perspective, that we're not applying a net force on there. By pulling on the cable on the right, having the equal and opposite force acting to the left, all we're putting on is a couple, no force.